Okay, this last video will be on the last topic, which is solving systems of equations. A system of linear equations can have three possible outcomes. There can be one solution, there can be no solutions, or there can be an infinite number of solutions. So, graphically, if there is one solution, it's where the lines intersect, and you can tell by if lines have different slopes. If there is no solution, then the lines are parallel, and you can tell that by the equations they have the same slope and different y-intercepts. And if there are an infinite number of solutions, then the equations represent the same line. So let's go ahead and do this. I like to graph in slope-intercept form, but you may not, so if you're using a different method, that's okay. If I have y equals negative 2x, that tells me that my y-intercept is 0. My slope is negative 2, so from this point I go down 2 and over 1, down 2 and over 1. And I connect my dots. I really want to be accurate when I'm doing this because I'm looking for an exact point of intersection. And you can't force it because sometimes it may not be nice, pretty whole numbers. But there's that line. If I put this in slope-intercept form by subtracting x from both sides, I get y equals negative x plus 3, which means my slope is negative 1, my y-intercept is 3. So I start at 3, go down 1 over 1, and again I want to do this multiple times so I can get a really good line. The slopes are different, so I know they're going to intersect somewhere, somehow. And so if I connect these dots, I can see that they intersect at this point here. That is my solution, and that is the point negative 3, 6. Okay, on B. This is in slope-intercept form, so I know I begin at 4. My slope tells me to go down 4 and over 1. Again, I'm going to do it a couple of times to make sure I get a really good line that represents that. And just remember that every point on this line is a solution to this equation. Okay. This one's not in slope-intercept form, so I'm going to add 8x to both sides, divide by negative 2, and I get y equals negative 4x minus 2. Okay, same slopes, different y-intercepts. That already tells me there's no solution, that the lines are parallel. But you need to graph the lines anyway. So negative 2, go down 4 and over 1, or I can go up 4 and to the left 1. Same thing. All right, so if I graph this, and lo and behold, there I have two parallel lines. So I would just write that there is no solution. Okay, this one, the one on the bottom, is in slope-intercept form. My y-intercept is negative 4, my slope is 1, up 1 over 1, and again I'm going to do this multiple times so I can get a nice pretty line. And if I connect my dots, there is my line. This one I'm going to have to put in slope-intercept form. So I'm going to subtract 2x from both sides. That gives me 3y equals negative 2x plus 3. Divide by 3, and I get y is negative 2/3 x plus 1. So that means I start at 1, my y-intercept, my slope tells me to go down 2 and over 3. Oh, and look, I've already found it. Yay! So my solution is 3, negative 1. Okay, so now we're going to solve algebraically. Now, solving algebraically we can do it any way we want, either using elimination, or we can use the addition slash, substitution, or the addition elimination. So if I have y equals negative 3x minus 9 and negative 2x plus 3y is equal to 17. You can do all of them using elimination, you can do all of them using substitution, or you can do what I do, which is I let the problem dictate what I'm supposed to do. Well, this already tells me what y is the equivalent of. So it's just like having 4 quarters or a dollar bill. They're the same thing. So I can take this and I can replace the y in here, or substitute, and that will give me an equation with a single variable. It appears twice, but it's still all x's. So now this gives me negative 2x minus 9x minus 27 is equal to 17. Negative 11x minus 27 is 17. Add 27 to both sides. Negative 11x equals 44. Divide by negative 11 and I get x is negative 4. Now, I'm going to take this and combine it with this equation. I know that y is equal to negative 3 times my x minus 9. Well, I know x is negative 4. So that gives me y equals 12 minus 9, so y is equal to 3. So my solution is negative 4, 3. If I were graphing, these would intersect at that point. Okay, so for B, I have 3x plus y is equal to negative 5, and 5x plus 3y is equal to 1. Now, if you wanted to solve this by substitution, you could solve this one for y pretty easily and then substitute it into here. But since these are all nice and lined up, to me it's just easier to just multiply this by negative 3, which means I have to multiply everything by negative 3, and I get negative 3x minus 3y is equal to 15. So when I add these equations together, I get 2x is equal, that's negative 9x. Oops. So that gives me negative 4x is equal to 16, which tells me that x again is negative 4. All right, then I'm going to pick one of the equations. I think I'll pick the top one. And I know 3 times x plus y is equal to negative 5. Well, I know my x is negative 4. So that gives me negative 12 plus y is equal to negative 5. When I add 12 to both sides, I get y is 7. So my solution is negative 4, 7. Okay, on C, I get 2x plus y is equal to negative 2, and negative 3x minus 2y is equal to negative 2. Okay, once again, this would be easy to solve for y, and then you could replace it in here. But since they're lined up like this, I want to do elimination. So let's see. I could either turn this into a positive and negative 6 or turn this into a positive and negative 2. I'm going to do that one. So I'm going to multiply this equation by 2. That gives me 4x plus 2y is equal to negative 4. When I add them together, I get x is equal to negative 6. I can plug this into either one of my equations. I think I'll do the top one. I know 2 times my x plus y is negative 2. Well, I know x is negative 6. So I get negative 12 plus y is negative 2. So y is 10. So my solution is negative 6/10. Okay, so now let's look at the application problem. So I've got them here, and we'll just do a sheet of paper to work the problem on. Okay, so for 19A. Oh, wait a minute, I haven't finished graphing. I mean, solving the other ones. Well, for heaven's sakes. I guess I just thought I had done all you needed me to do. Okay, so let's do D. If I have 0.05x plus 0.1y is equal to 5.25, and I have 0.08x minus 0.02y, that's equal to 1.2. Okay, now, if you don't like working with decimals, that's fine. You can multiply through by 100. However many places you need to move the decimal over is what you multiply by. So I think I will for this one. It's not really necessary, but you certainly can. So if I multiply this by 100, I get 5x plus 10y is equal to 525. If I multiply this by 100, I get 8x minus 2y is equal to 120. Okay. All right, this would not be easy to solve for one of the variables, so I'm going to go ahead and use elimination on this. I could look at these, but the signs are the same, and I would have to multiply this equation by 8 and this by 5. But this one, their signs are already different. And to get the same coefficient here, I would just have to multiply this equation by 5. So this becomes 40x minus 10y is equal to 600. So that one's gone. So now I can add these together and I get 45x, this is eliminated, is equal to 1125. And when I divide by 45, I get that x is equal to, so 525 divided by 45 is, whoops, I'm sorry, 1125 divided by 45 gives me 25. Okay, I'm going to go ahead and plug that into this equation. So I know that 5 times x plus 10y is equal to 525. And I'm going to take the 25 and put it in there. So that's 125 plus 10y is equal to 525. Subtract the 125, I get 10y is 400. So y is 10. So my solution is 2510. Okay. And then finally E, I have 4x minus 2y is equal to 8, and negative 8x plus 4y is equal to 12. Okay, so let's see. Let's eliminate the x this time. That means if I multiply this by 2, that'll give me a positive 8 and a negative 8. So this gives me 8x minus 4y is equal to 16. So this is eliminated. Whoops. This is eliminated. So I get 0 equals 28. That is never true. So there is no solution. There is no x and y that will make both of them true. There's a bunch of combinations that make this true, a bunch of combinations that make this true, but there is not a combination that makes both of them true. Okay, now it's time to move on to the application problems. All right, so let's see what we've got here. We have a student who invests $5,000 at 2 annual rates, 5 and 7%. After 1 year, the student receives a total of $325 in interest. How much did he invest in each interest rate? So that tells me what my variables are. So I'm going to let x equal the amount at 5% and y equal the amount at 7%. Now there are two things I know. Something equals 5,000 and something has a total of 325. Well, this is the amount invested and this is the amount of interest. Well, we know that the amount invested is just the x plus the y. Now the interest is going to be 5% of x, which is 0.05x. The interest here is 7% of y, which is 0.07y. Now again, you can turn this into decimals, you can do it by substitution, it doesn't make any difference. Again, I like to do elimination, so that's how I'm going to do this one. So, if I multiply this by negative 0.05, then I will eliminate the x's. So negative 0.05x minus 0.05y is equal to, and 5,000 times 0.05 gives me negative 250. Okay, so let's add them up. This is eliminated. This gives me 0.02y is equal to 75. So 75 divided by 0.02 gives me that y is 3750. So the amount invested at 7% is 3750. I know the total is 5,000, so x is the total minus this amount, which equals 1250. Okay, the second one is extremely similar. A bank has loaned out $75,000, part at 5, part at 8. They receive $52,500 in interest each year. How much was loaned at 5%? Well, they don't ask for both of them, but you're going to solve for both of them anyway. All right, so x equals the amount at 5% and y equals the amount at 8%. So, we know the amount loaned, which is x plus y, has to equal 750,000. The interest has to total 52,500. Well, the amount of interest is 5% of the amount loaned, so that is 0.05x. The amount of interest here is this amount, or 8% of this amount, so that's 0.08y. Again, I'm going to do this by elimination. I'm going to multiply this by negative 0.05. Again, you could solve for the x or the y, substitute it in, that's fine. So when I do that, I get negative 0.05x minus 0.05y is equal to 37,500. Okay, so I'm done with that. So I'm just looking at these two equations, adding them together. This is eliminated, so 0.03y is equal to 15,000. And when I divide that by 0.03, I get that y is 500,000. Well, the x is equal to the initial, or the total loans, minus this amount, which is 250,000, which is what the question asked for. Okay, C and D are rate time distance problems. So I know automatically that I need a table. So I know I've got a rate, I've got a time, I've got a distance. So I'm going to fill out a table here, and I'm going to see what goes in each spot. Okay, so a tugboat can pull a barge 60 miles upstream in 15 hours. The same tugboat and barge can make the return trip downstream in 6. Okay, so we're dealing with upstream and downstream. Okay. For each of these, we know the time and the distance. The distance is 60 miles, and upstream it takes 15 hours. The return trip means they're going backwards the same distance in 6 hours. So we need to find out about the rate, because we need to find the speed of the tugboat in still water and the speed of the current. So I'm going to let S equal the speed of the tugboat, and I'm going to let C equal the speed of the current. Now, when you're going upstream, the current is coming against you, and so when that happens, it's going to slow you down. So we're going to take the speed of the tugboat and subtract the current. When you're going downstream, in essence, it's giving you an extra push. So it's going to be the speed of the tugboat plus the help of the current. And I know rate times time equals distance, so this gives me my two equations. This times 15 equals 60. This times 6 is equal to 60. Okay, so I'm going to write this as 15s minus 15c is equal to 60. And this one is going to be 6s plus 6c is also equal to 60. Okay, from here, let's see what I'm going to do. Well, these are opposite signs, so I think I will eliminate them. The least common multiple of 6 and 15 is 30. 6 divides into 30, and so does 15. So if I multiply this by 2, and this, because 6 times 5 is 30, then this will give me the equation 30s minus 30c is equal to 120. This gives me 30s plus 30c is equal to 300. Okay. So this gives me 60s, this is eliminated, is equal to 420. When I divide by 60, I find the speed of the tugboat is 7. Okay, so the speed of the tugboat is 7. And it's in miles? Yeah, miles per hour. Okay, so to find the speed of the tugboat, I can just plug this into one of the equations. I'll choose the bottom one. So 6 times S plus 6C is equal to 60. This is a 7. So 42 plus 6C is 60. So that 6C is 18. So the speed of the current is 3. Okay. And our very, very last problem. A Boeing 767 flying west against a tailwind from Washington, D.C. to San Francisco, a distance of 2,400, and it should say miles, takes 6 hours. The return trip with a tailwind takes 4 hours. Find the speed with no wind. All right, rate, time, distance. Rate, time, distance. Okay, I know the distance is 2,400. And I know that the time going west takes 6 hours. The return trip takes 4 hours, and so that's east. But the key elements here are, it says west against the wind. So it's going to slow them down. And this is with the wind. Okay, so find the speed of the plane. So let's P equal the speed of the plane. Well, the stupid thing is still leaking all over. And W equal the wind speed. Okay, so against the wind, we're going to have to subtract the speed of the wind. So this is going to be P minus W. Oh, that's going in the trash. Okay. All right, and then this will be P plus W. So now I've got my equations. I know this and this is supposed to be minus. This times this is this. So I have 6 times P minus W is equal to 2,400. And 4 times P plus W is equal to 2,400. Okay, so this gives me 6P minus 6W is equal to 14,400. 4P plus 4W is 9,600. Okay. These are already opposite, so let's see what we can do here. The least common multiple is going to be 12. So if I multiply this by 2 and this by 3, I'll end up with negative 12W and positive 12W. So that gives me 12P minus 12W gives me 28.8. This becomes 12P plus 12W equals 38,400. Oops, that's not right because I multiplied by 4 instead of 3. So 9,600 times 3 is 20. No. Okay, I've done something wrong. Oh, this. I multiplied. No, that's right. Okay, well, hopefully you get the gist. I'm going to be real honest with you at this point. I'm not going to redo this because this is a 31-minute video, and for the last problem, if I need to, I'll tack on another video. So let me cut this one off, and then I will actually figure out what my mistake was and put it back up there.